So today, we're going to be talking about the method of common bases. So we're going to be solving exponential equations. An exponential equation is an equation where there exists a variable as an exponent. We will learn to solve these using the common base method. Do we have, what's an example of a variable? Give me an example. X, Y, A, Z, K. Is it just letters? No, there's more. We have a number of variables. We could use feet, miles. You could use star, like little symbols, as a variable. Sheep. I had a professor use sheep. He'd put sheep squared plus 3 sheep equals 7. Whatever you choose, that could be your variable. So, exercise 1. Solve the given exponential equation 2x, 2 raised to the x equals 16. So we need to find a common base. Our left-hand side, we have a base of 2. We want 16 to have the same base. So what exponent could I raise 2 to get 16? 4. Good. So 2 raised to the 4th is 16. I believe. Are they all pink or purple? Oh. That was green. So 2 to the x equals 2 to the 4th. Now we can set our exponents equal to each other because we have the same common base. So our exponent on the left is 2 raised to the x, so x equals 4. It's as easy as that. Yeah. We can check this. Is it this one? Okay. So to check, we're going to use the store button. X equals 4. What's our equation? Two. That is true. So this is how we check. X equals 4. We store that, and then we plug it into our equation. Go ahead and try B. We should always check. What's our common base? 3. So 3x equals 3 raised to the 3rd. 3 raised to the 3rd is 27. So now what can we do? Set our exponents equal to each other. X equals 3. And we would, after this, check it. Go ahead and try the next one. Our common base. Our common base is 5. 5 raised to the x is equal to 5 raised to -2. Our bases are the same, so we can solve. Okay. X equals -2. And then we check. Solve D. We need to find a common base. So we said our common base was 4. So our left-hand side, 4 squared raised to the x. Power raised to a power, we multiply. So our left-hand side should look like 4 raised to the 2x. And our right-hand side is 4 to the first. Do we have common bases? Yes, so now what would we do? 2x equals 1. We set our exponents equal to each other. And then we divide. It is 1/2, not 0.5. We're using fractions. 1/2. Any questions? Is that all right? Yes. Because we want to find a common base. Yes, we have to find a common base. And our common base here is 4. So what we want to do is find a common base between our left-hand side and our right-hand side. We need to go over, we're going to do some simplifying of some exponents. So when we said we have 2 ways to solve this problem. We could either, what's 2 raised to the third? 8. And then we have x, so 8x. Or multiply what? Okay, does everyone see that? 2 cubed is 8. Or we could use our power raised to a power. So 3 times x is? Okay. Those are the 2 different answers for simplifying our expression. So either we can square our number, 2 times 2 raised to the third is 8, or we could power raised to a power. We could have 3x. Questions? No? Does that make sense? Try part B. First way, what do we get when we square 3? So we have 9 raised to the 4x, or 3. We distributed 2x, or 2, so we have 2 times 4x is 8x. Question? No? C. First way, what's one way we could solve this? Or simplify this, I'm sorry. Simplify. 1/2. So 5 raised to the negative 1 is 1/2. 1/5. Raised to the 3x minus 7. Or we could distribute the negative 1. Distribute the negative 1. Negative 3x plus 7. Try D. All right, what do we do? Distribute, okay. What are we distributing? Negative 3. So we have minus 3, so it's plus 3 plus 3x squared. Other way. Good. So with example number 3, what do we notice different about this one compared to our? Do we have a common base? No. Do we have to find a common base? Yes. What would our common base be for 8x equals 32? 8? Can we raise? We need to find a common base. 8 and 32. 2? Okay. Why couldn't we use 4? We said we could use 2. 2 raised to what is 8? 2 raised to the third. Okay. 2 cubed raised to the x equals 2 raised to the 5th. Yep. Now I can, to my right-hand side, I should power raised to a power. Left-hand side, multiply 2 to the 3x equals 2 to the 5th. We have the same common base, so we can set our exponents equal to each other. 3x equals 5. X equals 5/3. Common bases, left-hand side should look like 3 squared raised to the 2x plus 1. Right-hand side, 3 raised to the 3 cubed. Now I need to distribute the 2. So our left-hand side, 3 raised to the... Good. Right-hand side is just 3 cubes. Set our exponents equal to each other. Subtract the 2. Four x equals 1. Divide by 4. X equals 1/4. Go ahead and try C. We need to find a common base. 25 over x, or 125 raised to the x, what should our base be? 5. 5 raised to the third. Our right-hand side equals, remember our exponents rule with a negative makes it a fraction, so that's how we got -2. So that is raised to 4 minus x. Okay. Now we power to a power, distribute. We keep our base, so 5 raised to the 3x equals 5 raised to the -8. We distribute the -2, distribute the -2 to, so negative times negative, positive. We have the common base, so 3x equals -8 plus 2x. Subtract 2x. Left-hand side we have x, right-hand side -8. Can we check this? Yes. Should. What? Yep. Skip ahead to exercise number 5, please. We're skipping exercise 4 and going to 5. Common base, 5. 5 raised to 2 raised to the x squared minus 5x equals 5 to the third raised to x minus 2. Distribute 5 raised to the 2x squared minus 10x equals 5 raised to the 3x minus 6. Common base, so we can set our exponents equal to each other. 2x squared minus 10x equals 3x minus 6. So we subtract 3x plus 6, both sides, and we should have 2x squared minus 13x plus 6 equals 0. AC method. Two x minus 1, x minus 6 equals 0, x equals 1/2, and 6. Homework is pages 14 and 15.